Alright guys, welcome to Formatics. In today's video, we are going to be solving a question. A student asked us to solve this question on problems involving intersections of line and circle. In our last episode, we talked about problems involving intersection of lines and circle. From that episode, I received a question from a student that I should solve in my next episode. So in this class, I'm going to solve this question as the solution or feedback to the student that asked for this. If you can solve the question, please feel free to try it out. Pause the video. When you are ready to see your answer, please come with us and let's see the answer together. Okay, before we move into this video, let me quickly take a recap on problems involving intersection of lines and circle. In the last episode, I mentioned it that to solve problems involving lines and circle, it will tell you that you should verify whether the line touches the circle or not. And if the line touches the circle, is it at one point or at 2 points? When the straight line touches the circle at a point, we said it's a tangent to the circle. When it touches it at 2 points, it's called secant. And I told you that you will solve the two equations simultaneously using substitution method. You substitute the linear equation into the circle equation. Then, if your b square less than 4ac, that means the straight line did not touch the circle. But if your b square equals to 4ac, that means it's a tangent to the circle. The straight line is a tangent to the circle, meaning that it touches the circle at a point. But if b square greater than 4ac, it's a secant. It touches the circle at 2 points, and you can calculate the coordinates of the 2 points. Come, let's look at the question together. Okay, the question we have at hand says the line 2y minus x is equal to 12 intersects the circle x squared plus y squared minus 10x minus 12y plus 36 equals to 0 at the point AB. So this is a second question. The straight line touches the circle at points A and B. Find the coordinate of points A and B. That's question A. Question B says, find the equation of the perpendicular bisector of AB. And question C says, the perpendicular bisector of AB intersects the circle at the points P and Q. Intersected the circle at points P and Q. So, find the exact coordinate of P and Q. The same circle. The questioner said, question D, find the exact area of the quadrilateral APBQ. Okay, let's look at the questions together. All right. Here are we have the solution to the question here. Let me take you through it. We are given the linear function of that equation to be 2y minus x equals to 12. Let's call it equation 1. And the equation of the circle as x squared plus y squared minus 10x minus 2y plus 36 equals to 0. I've told you that we are going to use substitution methods to show that the straight line touches the circle. I need to write this 2y minus x is equal to 12 in the form of a linear form that I can make either x or y subject of the formula. So it is easier for me to make x the subject of the formula. To solve question A, which asks me to find the coordinate of point A and B, I'm making x subject of the formula in equation 1, and that will give 2y minus 12. And I will substitute this into the circle equation 2 that I have here. Wherever I see x in equation 2, I put 2y minus 12. So I have x squared. Instead of writing x squared, I put 2y minus 12 all squared plus y squared minus 10, instead of writing x, 2y minus 12 minus 12y plus 36 equals to 0. The next thing I do is I simplify. When I simplify and expand the bracket, I take the square of 2y, which will give me 4y squared. 2 times 2y times 12 give me negative 48y. And I take the square of negative 12, which is 144. So the expansion of 2y minus 12 all squared gives 4y squared minus 48y plus 144. I transfer my y squared down plus y. Then I expand with minus 10. Expand 2y minus 12 with minus 10. Minus 20y minus times minus give plus 10 times 12 120 minus 12y and plus 36 equals to 0. I quickly collect like terms. Those ones that have power 2, 4y squared plus y squared gives 5y squared. Negative 48y minus 20y will give me, and 12y, the three together will give me minus 80y. And the constant term 144 plus 120 plus 36 gives 300, all equals to 0. I can reduce this quadratic equation by dividing through by 5. Yes, just to reduce it. So 5 divided by everything will give us 5 will be y squared minus 16y plus 60 equals to 0. When we solve this quadratic equation by factorization, y minus 10 will give us y minus 6 equals to 0, which tells us that our y is 10 or 6. Then I have the value for y. Now I can substitute this in my equation 1. Okay? I know that from equation 1 I have x is equal to 2y minus 12. So when y is 10, I will replace that with my value of y. X is equal to 2. When y is 10, I put in 10 here, then minus 2, which will be 20 minus 2. Okay? When x is 8, rather, I have 8. 8 times this, that gives 16. Okay? That gives 16. 2y minus 12. So 2 times, apology. So my y is 10 or y is 6. If y is 10 or y is 6, I substitute this in this equation. So x is equal to 2y minus 12. So when y is 10, I will have 2 brackets 10 minus 12, which will give me 20 minus 12, which is 8. That's where I have x to be 8. When y is 6, I'm going to substitute when y is 6. When y is 6, so I'm going to have 2 brackets 6 minus 12, which will give me 0. And that's what I have. The required coordinates of A and B will now be 0, 6 and 8, 10. 8, 10. And that is question A that we are asked to do. Question A asks us to find the coordinates of A and B, and that is what we have seen. Okay, question B asks me to find the perpendicular bisector. Okay, let me quickly show question B. We've done question A. Okay, we've done question A. We've done question A. So we just do question A, done. So we are coming to question B now. We've done this. Question B now says we should find the equation of the perpendicular bisector of AB. Perpendicular bisector of AB. Okay, let's quickly check that. Perpendicular bisector of AB. Now, to calculate perpendicular bisector, we need the midpoint of the coordinate that we've just done. So the midpoint of that coordinate the midpoint of the coordinates 0,6, 8,10. In one of our episodes, I've taught you how to calculate midpoint. I've told you midpoint is the average of x components, that's x1 plus x2 all over 2, and the y part of it will be y2 plus y1 all over 2. So my x here is x1. I have 0 plus 8 over 2, 6 plus 10 over 2 for the y component, which will give me 4,8. I quickly need to calculate the gradient too. The gradient, if I'm to calculate the gradient, I will use at the gradient of AB. The gradient of AB is change in y over change in s. I've told you that in one of the episodes. If you have not checked that, if you have not seen it, go check it out. So the gradient of this will be, 4 over 8. The gradient is 4 over 8, which is the same thing as 1 over 2. Then the perpendicular bisector of AB, if the gradient of that line, I've told you, the perpendicular bisector of any line, the product should give us -1, meaning that the perpendicular bisector of that, the gradient of the line perpendicular will be -2. -2. I told you the gradient will be 1 over m1, -1 over m1, which will be -2. So that is where we arrive at the perpendicular bisector to be -2. Okay, m1 times m2 should be -1. So the equation of the perpendicular bisector using vy minus y1 is equal to m open bracket x minus x1. Our gradient is -2 and our midpoint 4,8. Okay, I substitute that in this equation. Y minus our y in the point minus 8 is equal to, okay, is equal to -2 open bracket x minus 4. If you do that, the required equation will be y is equal to -2x plus 16. And that is question 2 or question B of this part. Okay, that is how to do question B. What you just do is find the midpoint, which is perpendicular bisector of that thing, and you find the gradient, and with that gradient you can do the two together. Okay, let's continue. And so that means for you to calculate that B, just get the midpoint from the formula and get the gradient. Then we know the perpendicular bisector is m1 times m2 equals to -1, where m1 is that of the straight line and m2 is the perpendicular line. So that makes the perpendicular to be -2 here. And that's how to do question 2. Question B. Question C says we should find the coordinate of P and Q that lies on the circle. So from the equation we have, y is equal to -2x plus 16. This is the perpendicular line. And we are told that that perpendicular line also lies on the same circle. So for us to get the points P and Q, we repeat the procedure we did in A for the new linear straight line graph and the circle. So when we solve simultaneously, if we solve that simultaneously, we are going to have this minus y is equal to -2x plus 16, call it equation 1 and the equation of the circle again. Substitute for y in the circle equation, x squared plus -2 plus 16 squared minus 10x minus 12 open bracket -2x plus 16 close bracket plus 36 equals to 0. Okay, so let's expand. If you expand this, you have x squared is equal to 4x squared minus 64x plus 256. Then we are going to put down the -10x minus 12, use the 12 to expand, 24x minus 192. That is 12 times 16, 192, plus 36 gives 0. Collect like times all the power of x, that's 5x squared, all the coefficient of x. That should give you minus 50x plus 100. I can reduce this to the lowest term by dividing through by 5. So I have x squared minus 10x plus 20 equals to 0, and that's my quadratic equation. If I use quadratic formula to solve this, where a is the coefficient of x squared and it is 1, b is coefficient of x which is negative 10, and the constant here is 10. Let's substitute that in quadratic formula. Then we are going to have x is equal to 5 plus root 5 and x is equal to 5 minus root 5. We have two distinct answers. Then when we substitute this back in our linear or straight line equation, we substitute x is equal to 5 minus root 5 into the answer, and what we will get is 6 minus 2 root 5. Okay, and when we substitute when x is equal to 5 minus root 5, we get 6 plus 2 root 5, leaving us with the coordinate of p and q to be 5 minus root 5 comma 6 plus 2 root 5, that is for p, and for q 5 plus root 5 comma 6 minus 2 root 5, vice versa. So that is the answer for question C. Question D now asks me to find the area. I first drew out the points. This is the line and this is the perpendicular one. This is the coordinate for point A, the coordinate for point A, coordinate for point B, coordinate for point P, and coordinate for point Q. To find the area of this quadrilateral, we know that the length of diagonal half times the product of the diagonal. For me to know the product of the diagonal, I need to know the length of AB and I need to know the length of PQ. For me to do the length of PQ or AB first, I use the length of a line. Okay, length AB will give me square root of 8 minus 0, that is change in x square plus change in y square, which will give us root 80. And the length of PQ, I'm going to find change in x minus change in y, 5 plus root 5 minus 5 minus root 5 all square plus 6 minus 2 root 5 minus 6 plus 2 root 5 all square. If you do this carefully, your answer will be 10. So I have the length of AB to be root 80 and the length of PQ to be 10. The area of ABPQ is equal to half times root 80 times 10, which will give me 20 root 5. Very simple and straightforward. Please, I will enjoy you to go over the video again for you to know whether you are okay with the solution or you still want to check one or two things. So I will leave you with this following question. Please practice this. Yes, they are just simple problems on the intersection of line and circle. See you in my next video. Do enjoy the rest of the day. Bye.